Curved inlays are kind of like the holy grail of woodworking. They're something that you're always looking for, but you can never quite find. And in this video, I'm going to show you the secrets on how to do curved inlays using Autodesk Fusion. So I highly recommend you watching my previous video on how to do 2D inlays with Autodesk Fusion, because all those concepts are going to come into play here for doing 3D curved inlays. And I create a plugin that makes it really easy to do inlays. I recommend going ahead and downloading, installing it, because I'm going to be using it. You don't have to use the plugin. You could also just run it and see what it generates and copies it, or copy what it does, and it's really up to you. And I thought it'd be fun to create something that'd be interesting. And so this is a spherical object, which would be difficult to machine itself, but I'm going to document exactly how to do it, and we're going to have some curved inlays on it. So let's start by jumping into Fusion, and I already drew the sphere up, and let's actually do the inlays. And of course, you can download the project for this. I'll post a link. It'll be free to download, and you can play around with that file and try machining this yourself. Let's do a really quick walkthrough of the basic sphere design project, and you can download this basic project and follow along and create the inlays yourself if you want. The link will be below. So what we have here is, if I roll back in the timeline, create a new component for the sphere, and inside that component is the actual sphere. Then I split the body in two and moved each of those into their own components. So we have a top and bottom of the sphere because we want to machine just half of it. And in order to indicate the two in, I made a sketch for the holes, and that's going to be filled in with some dowels so we can link the two together, and we'll also use it for alignment. The other thing that I like to do is I like to model the stock. So when I'm pumping through the timeline, the next thing we see is the stock component that's created. And if I go to the end, we can see that there is an opaque or transparent stock that's created on top of everything. And that's a very specific size. And I went and created it with a sketch called the stock base. And I like my stock to be translucent, so I right click on it and I create the opacity to be like 30% or 40%. And let's go ahead and hide the stock. One of the basic prerequisites to creating a curved inlay is to be able to machine your basic shape. So let's talk about the cam that I do to create and make this half a sphere. So go from design over to manufacture, and I already created some setups that do the basic cam. The first one, and I'm going to go ahead and click on this guy, and I mentioned this in the last video, but I like to check sync view with active setup and sync visibility with active setup turned on. It's going to really help a lot when you have complex projects. So I activated spoil board holes, and so what we're going to do is expand this guy here. The first thing is a drilling operation, and I'm going to just go ahead and we're going to not actually have that green stock there, but we're just using that as an origin location. And the blue area, if I hit the front view, we can see I'm going to be drilling down. And so this is just a drill toolpath where I set the height. The top height is the stock bottom, and the bottom height is the stock bottom, offset by negative 0.4 of an inch. So that's going to drill my spoil board alignment holes. And what we'll do is we'll drill that into a piece of temporary MDF, and that will allow us to line everything. And another thing that I do is, since I modeled this stock in this setup, if I look at the setup, the stock is set from solid to stock, and my origin is the box point. It is that lower left of the stock. And this is something that we're going to have to repeat a lot of times. It's very important to do. If you just use a fixed size box or relative size box, the origin is going to be slightly inset and things will be off and it will not work out. So make sure you're going from solid. You select that stock model and your origin is the bottom left. Okay, so back to the alignment holes. I duplicated the whole first one, the spoil board holes, named it alignment holes. And if I click just from one project to another, one thing we notice is here's my origin in the bottom left. I click the other one, the origin is going to be the top right. If I actually activate it, flips it around, and I can see we're on the bottom. And the only thing, or the way you do this in your coordinate system is I selected a custom z-axis, y-axis, flipped it, and made sure that my axis was pointing where I wanted it to be, and the origin was correct. Now, we want to have these spoil board, or we want to have these these holes for the two-side operation to be drilled into the stock. And so it's the same thing as before. It's a drill operation, except the top height stock top, bottom height is stock top minus 060, minus 0.6. So that's going to drill some alignment holes. And then let's look at the next one, which is back to the top. So again, it's flipped over. I'm going to flip it. So if I go from just clicking on 0 in my first setup, I can see origins lower left, alignment holes upside down, the top left, and upside down, and then the sphere half back to the lower left. Going from 0 to 2, the origin does not change, which is very important. So inside here, we're going to machine the first thing. The roughing pass is going to be a 3D adaptive, and I'm using a 3/8 of an inch upcut bit and doing an aggressive machining. And if you have a machine that's not as rigid, like a hobby-based machine, you're going to probably want to change it to, instead of doing a 3D adaptive, you're going to probably want to use just a regular 3D pocket clearing, because pocket clearing is a lot easier on the machine than 3D adaptive. And the things I did in 3D adaptive, 3/8 of an inch spiral upcut bit, stock to leave is 020, maximum roughing step down 375, and a fine step down of 375. And really that's the basics for it. And then for a finishing toolpath, I'm going to do a scallop, and it looks like a nice path. I'm going to use a 1/4 inch ball nose to do it. One of the things to notice is it actually goes below the origin here. If I double click on the toolpath here, one thing I did set is on the heights, the bottom height is going to go below by 1/8 of an inch. And if you don't do this, it's not going to just go all the way to the bottom, and you're going to have a seam at the bottom that you're going to have to sand off later. This also means it's going to actually machine into your spoil board, so it's important to have a temporary spoil board to do this operation. So let's jump into the shop and actually go ahead and make this thing. So the starting stock size is 5 1/4 by 5 1/4 by 2 5/8 of an inch tall. And this size is pretty convenient to make out of a piece of 8 1/4 and 4 1/4 inch stock wood. It gets you to the right height. You can just glue a few of them together at once and then cut them to the right dimensions on the table saw. Here's my workpiece, and I don't want to directly mount onto my spoil board because I want to machine everything away, and I want to machine into the spoil board alignment holes and also a little bit of extra depth. So I could use a temporary spoil board, and then I can use double-sided tape to mount this guy on. I want this to be my origin, and so I want it to be like this, right here tight against it, but that wouldn't give me somewhere to actually clamp onto, so I want it to be inside a little bit. And instead, what I really want to do is just outset my temporary spoil board, and an easy way to do that is just notch it, and you can outset a little bit and have an area to clamp down, and so that's what I'm opting to do. So I clamped down the spoil board and drilled those alignment holes first. The workpiece then needs the corresponding alignment holes on the bottom side of the piece. So on the top side, I put some double-sided tape down. I don't use a lot of tape for this because it's not a very aggressive machining operation. I popped the piece off the work table and I put some double-sided tape onto the bottom. I try to avoid the spoil board alignment holes. I toss in a few dowels and make sure it clamps down nice and tight. And one of the things that I like to do is I like to use a clamp to clamp the mini spoil board to the workpiece to ensure you get really good adhesion from the spoil board to the workpiece. And this is because I'm going to do some really aggressive machining. So I clamped it back down and I'm all set to run that third machining operation, the sphere half. And I start with a 3D adaptive. It removes most of the material. And again, if you don't have a rigid setup, you may want to just do a normal pocket clearing. So it's back into Fusion to actually create the inlays. And so for an inlay to work, we have to project it down onto the object we want to target. And I'm going to create an offset plane to do that. So let's go ahead and show the origin. And I'm going to click and hold and select the XY plane here. And I'm going to go construct, offset plane. And let's go ahead and look at the front, and I can just drag this plane so it's above our shape. All right, we have the offset plane, and now let's go ahead and create the design here. I'm going to create a new sketch on that plane, and let's look at the top. Again, I have look at turned off. Hit C for circle, kind of snap to the middle, and let's just create a circle. And this will be our basic inlay shape, the first one. I'm going to hit finish sketch. Let's go and rename this to be the circle. And let's run my plugin to create the first inlay. Create Inlay VCarve. And I talked about this in the first video. I'm going to hit cancel. We go back over to manufacturer tab. And I preloaded in the tool library for this particular project. I have tools that I already want to use, an 1/8 of inch taper ball and a 15-degree V-bit that I want to use for this particular project. It's important to preload them. If you don't, not a big deal. You can actually add them later. So I'm going to go create VCarve Inlay. And before I do this, I want to organize things a little bit better. Let me go ahead and we got the main component, the root component currently is what active. I'm going to click new component, and we're going to call this top inlays to just group things together really nice. And it's now active. Now I can do create VCarve Inlay. We're going to call this the circle inlay. I'm going to select the circle sketch. Either I could click on it in the design space or over here. Target a 3D body because we want to do a 3D shape, and we want to use a depth of about 100 thousandths. It's pretty good. Create a plug, and Toolpaths. 15-degree V-bit is what I'm going to be using. I'll link to the bits I'm going to actually use for this project. And an 1/8 of an inch taper ball for clearance. Hit OK. And so I'm going to zoom out, and let's go ahead and color things so we can actually see what's happening. I'm going to expand this top inlays. So we have 4 components that were generated. A for appearance, and I'm going to drag the 3D walnut to the pocket, and then I'm going to drag the 3D maple to the inlay. And I'm going to go ahead and close the appearance. And so we have a curved inlay to generate basically half of an 8-ball. You can lift it up and see that this is all a curved surface. Hit undo. And I want to capture the position of the plug. If I hit the revert position, it goes back to where it was created. I'm going to undo, and I'm going to hit capture position. So let's take a closer look at what was generated. We have the pocket, and if I hide the inlay, the next portion, you can see that that's the cutout portion that the inlay will fit into. The inlay is the physical part that goes into it, and the inlay is kind of purely ornamental. We won't really be using it. It's just for looks. The plug is what's going to fit into the inlay, and the plug has a plug stock, which is shown ghosted, that increases the depth of the plug for when we actually machine it to fit in properly based on the parameters. And I talk about these pretty extensively in the last video. Now let's go ahead and customize the actual size of the plug because we want to make it out of a particular piece of stock. And so on the circle plug, I'm going to expand it, and we could go ahead and activate it. And let's go ahead and expand the sketches. And we have the plug profile sketch. I'm going to double click on that. Double click on it, not the title. Double click. I'm going to hit look at it. And what this is the size of the plug with regards to the inlay. We want to have a known size. I'm going to hit the perpendicular constraint. And let's just make sure we're starting everything square by constraining these guys to be perpendicular. Now I'm going to hit escape. I'm going to select this guy, hit D for dimension, and 2.119 is the dimension that was the minimal size for the plug. Let's make it like 2 1/8. And then the same here. Let's make this guy 2 1/8. And we could make it bigger. We could make it like 2 1/4. Maybe that's a little bit easier. 2.25. And if we did this, we would drag the shape and kind of get it all centered, maybe use constraints. And after I hit finish sketch, our plug is auto-created with the new size, which is really handy. I'm going to go ahead and activate the test sphere again. And so now we can go over to the cam and take a look at how we're going to set up our cam to actually machine the plug. So manufacture, and we have some tool paths that were automatically created, some tool setups. Let's look at the pocket first by activating it. And if I expand the pocket, and let's change a few things because we want this shape to have the same origin as our sphere half. And this is pretty important. So if I click on sphere half, notice the origin popped out compared to this one. So we want to use the same origin, and that's really important for machining. And I'm going to double click on this pocket, and we're going to take a look at some of the things that are set up here. So the stock is set up to be a body, and the stock body is the original sphere half. And if we look, we see the lines over in the models section. Could expand it. It's set up to be the sphere, and it's set up to be the top sphere half. If I expand it, it's the bodies, that actually top body. They're all hidden because it's not part of what we're machining. It's just the stock model. So setup, I would select my machine at this point, but what I really want to change is the stock origin. And what I want to do is I want to pick a model, a selected point. We want to pick the same origin that the last one had. And there's a few ways to do it. Let's do it this one way of explicitly selecting it. So we modeled our stock up. I'm going to go ahead and expand this guy, show the stock. And one of the reasons I modeled the stock is it gives us a very consistent reference point, this origin right here. And we want to select that as the origin, hit OK. Now if I click from sphere half to inlay pocket, the origin is the same, and that's very important. Now let's look at the toolpaths and see what we want to actually do here. They're all invalidated, so I'll hit Command G to start generating these guys. So let's take a look at the toolpaths. The first one's the VCarve outline, which will carve the basically the actual VCarve, and this one's really simple. And it's going to do a clearance and remove out the middle, and this is using a scallop operation. And then a V-bit rest, so anything that clearance bit and it had a ball nose, it wouldn't be able to get in all the edges. And I talked about this in the last video, but basically the way that things like the clearance work, if I double click on it, the main trick here is the geometry tab. And the machining boundary is limited to sketch profiles, and that's the profile of the plug, or sorry, the actual inlay, and then it's inset by specific amount. Click on the three drop downs at expression, and we see that it's inset by the pocket stock to leave, which is just mathematically computed based on the angle. It's a parameter. Something that you might want to do when you're doing some 3D machining is you might want to do more roughing passes before, so that your finishing bit doesn't go and just do a lot of chunking down. So in the clearance one, I will frequently right-click on it, create a derived operation, 3D milling. We're going to go a little mellow. Let's use pocket clearing for this. And let's just select a different bit, maybe a 1/4 inch upcut bit. And let's go ahead and look at some of these parameters. We don't want rest machining on. The geometry is going to be limited like the last one. And the heights are probably okay to not have to modify. We want to probably leave stock to leave to be 020. I'm not sure why it defaulted to the weird thing. And set your roughing step down to what you want, maybe 30 thousandths of an inch. And so what this will do is just rough out that pocket, which will be nice. In fact, we'll drag it and move it to the first thing that we do. So this will be the operation to do the inlay. So let's go ahead and cut that out. So I went ahead and ran these toolpaths to create the pocket for the inlay. Back over to Fusion, let's take a look at the plug and see what we have to do for that. So I'm going to activate it, which is going to show it. And let's go ahead and expand it. The toolpaths were all invalidated, so I'm going to hit Command G to regenerate them all. So if we look at the plug setup, I'm going to double click on it to bring up the setup. And I'm going to go to the stock tab, and the starting stock for the plug is the circle plug stock. And if we go to over here in the browser, top inlays, let's hide some sketches. So that's this circle plug stock that was auto-generated. And this is going to come back in just a second. The setup origin, bottom left, and the model is the plug. Now if we take a look at the toolpaths generated, the first one's going to go ahead and cut the VCarve. Then it's going to do a clearance to remove the extra stuff. And again, we will probably want to do a roughing pass. And then a V-bit rest to remove the extra. Now what's special about this is if we look at the side, the last video talked about this, but the main trick to actually generating a deeper plug is the extra stock that's created. So this part in yellow, it lets the plug go deeper than what was created in design. And it's hard to tell for a shallow one, but when I go ahead and step through these guys, it's quite a bit deeper. And it says very specific amount that can be controlled via a parameter. And that's the main trick to being able to do a V-carve and tweaking it to fit. However, the thing about 3D inlays is the starting stock, it's got a shape already. And so we have to machine that starting plug shape. And let's go ahead and do that. We probably want to create a new setup for that. And there's lots of ways to create a new setup. We could just create one from scratch. So I'm going to hit new setup. And we want to machine the plug stock body. So I'm going to go ahead and if we're going to find that, top inlays, circle plug stock. And I'm going to go to stock. I don't want it to be from preceding. Let's do a relative size box, no additional stock. So we need a 2 1/4 by about 3/4 of an inch tall piece to create the plug. Go back to the setup. And again, I like to use the bottom left as my origin. So stock point, bottom left, okay. We're going to call this circle plug stock. And I'm going to collapse the circle plug. We will actually have to do this one to create the plug stock before the plug. Now I'm going to go ahead and copy just some standard machining parameters from where I did this earlier. If I go to my circle plug stock, copy, and paste. And so what I'm going to be doing is we're going to do a 3D adaptive to remove most of the material, and then a scallop to go ahead and finish it off. 3D adaptive, and then a scallop. And that'll create the plug stock. So we have to run this toolpath first to generate our plug stock. 3D adaptive might be a little bit aggressive again, so doing a 3D pocket clearing might be a lot better. So I went ahead and ran those two setups on my CNC machine, and that gave me my plug for this circle inlay. I usually will take an X-Acto knife and just trim off any fuzzies on inlays, and that way that will ensure that they mate correctly. Note that I machined my plug at a different location on my CNC table, and that's totally fine to do as long as you save the origin for that sphere somewhere. And I use workspace offsets. I'll post a link to a video for how to use these. And those black dogs on the spoil board will allow me to reorient the piece at exactly the same location. So I can pop it off and glue in the inlay. After the glue dried, I could mount back on the CNC table at that same location. And the next step we have to do is to clean up that plug. So let's go back into Fusion and do some CAD and CAM for that. So for the plug cleanup, essentially what we want to do is run the same toolpath for the sphere half. I'm going to activate it. Run this exact same toolpath. And we could just duplicate it. So I'm going to right click on it and duplicate it. And so we have a duplicate of it. And we could drag the order. And if we do that, we have to be careful about some things, because sometimes if you reorder things, if I double click on this guy, the stock is set to from preceding setup, which is, I don't know, that's not really what we want, sort of what we want. We can leave it here and do that, but just be cautious about this. If your origin is different, when you click on back and forth between these two guys, in fact, let's go rename this guy to make it more clear. Let's call it 3 plug cleanup. You have to make sure the origin is exactly the same. And if it's not, then you're going to have issues. And I accidentally machined the wrong thing one time with the wrong origin and got some stuff cut where it shouldn't have been cut. So just be careful about that. Let's expand this guy, and 3D Adaptive is pretty aggressive for plug cleanups. So let's right click on it, create arrived operation. Let's do pocket clearing, and I'm going to set the roughing step down to 0375. Stock leave is 020. Drag that to be first, so we do a pocket first. Not going to do the 3D Adaptive, and then we'll do a scallop to clean up. But we don't want to just do everything because it's totally unnecessary. So I'm going to double click on the pocket, and let's go over to the geometry tab, and let's limit where it's going to cut. And we want to cut just where the plug is. So I'm going to go from machining boundary to be none, or bounding box to selection. And let's go ahead and find what we want to limit it to. So if we look at that circle inlay, if I expand these guys, let's show some things on the side. We have the circle pocket, and the circle pocket's where we want to clean up. We have a machining boundary sketch that it already generated for the pocket. And for this particular operation, that's pretty much kind of where we want to clean up. It needs to be a little bit bigger because the plug's square. So let's go ahead and actually draw where we want to clean up. So I'm going to go back over to Design tab, and let's go and look at our top sketches. And let's create a new sketch on the top. Again, we have a plane that we already created for the top. Create a new sketch, and I'm going to call this one the plug cleanup. I'm going to look at it on the top. So here we see the size of the plug. I'm going to create a rectangle. Let's create a rectangle from the center to ensure we clean up that whole area. We could just do a project of that shape, not link it, hit OK, and double click on this guy, move it with an M, and I could move that shape over here, and that will give us the size of the plug we need to clean up. There are more precise ways to do this, but this will work perfectly fine for this type of thing. Go back to manufacture. Now we have that area that we want to limit the machining, so I can double click on the pocket, go over to geometry, and we're going to go machining boundaries may be selection. We're going to select that area as where it's going to go. Let's let the tool go outside that boundary. Let's look at the front and think about the depths. Think about how high it is extending above it. If your plug is really deep, you might need to start a little bit higher than stock top, like maybe stock top plus 100 thousandths. And then you probably have to move your retract to be above the top height by that much. And so that's going to go ahead and machine out the plug with the pocket operation. The simulation is showing the entire original stock, which isn't a big deal. And the scalp we want to limit in the same way, so geometry, selection, machining boundary here. Let's let the tool go outside the boundary. And this will probably generate way more, or a larger area than we really need. In fact, I know that we probably want to limit it just around that circular area of the plug, of the inlay. So on the inlay pocket, we have a sketch for the machining boundary there. That's more appropriate for what we want to do. And that'll just clean it up circular, which will be nice and right where we want. So I can go ahead and post-process this operation. And I'm not mentioning it, but you should probably run simulations for everything. This simulation is not going to work out because it's basically machining the entire stock, which it's physically not doing. So it's kind of hard to really trust what it's doing here. So I'll post-process this and run it. I then went ahead and ran that toolpath to do the cleanup and immediately started doing some more. And so this is a VCarve inlay to create the 8-ball, the 8 in the 8-ball. I basically did the same process with the plugin to generate the 8 and just did it again in the top and machined out the 8, glued it in, and machined off the top. And then I could split it away from my mini spoil board. For the bottom side, I wanted something a little bit more challenging, and so I did the same steps to run the plugin with this eagle image that I found on the internet. And notice that the plug is very curved, and this is a very curvy inlay. It's also got a lot of detail and a lot of little sharp bits that are going to be really hard to V-carve. So let's see how this turns out. Machining the plug was the more interesting part of this project, and I ended up doing 2 plugs. So the first one here is done in face grain, and what I found is the face grain one, it just had a lot of chip out in the little pieces. It just really wasn't holding together well enough. So I made another version using ingrain just for the plug, and it really held together a lot better, which kind of makes sense if you think about how wood grain works. So I decided to use the ingrain plug just because it looked a lot better, and I went ahead and glued it in, and then put it back on the machine, and then did a plug cleanup path. Again, all these toolpaths are in the file that you can download, so you can check it out and see what I actually did. Sanding is kind of the nemesis of all woodworking, and you have to do it. I did a little bit of it before gluing the 2 halves together. And of course, those alignment dowels allow you to align the 2 halves perfectly and glue them together, pop them off, sand it, toss a little finish on, and let's see how it turned out. If I take a look at the inlay and I'm critical about it, I can see what happened on the face grain of the walnut. I had some chip out right here, the eye disappeared, but other than that, we got a lot of really sharp corners. It's really impressive the amount of detail that this turned out to have without losing certain things. We did lose some of the walnut into little areas here, which is kind of expected based on how face grain orients. Overall, I'm really pleased with how that turned out. Taking a look at the 8 though, it was just really tight, a really simple carve, and really not any issues at all. That turned out perfect. So I made this project with the sole purpose of showing you guys how to do curved inlays. And really that was the main point of it. I did it just for fun and really just for you guys. So feel free to ask me questions because I'm sure I glossed over things a little bit too quickly. I'm happy to help you out. Download the CAD file. I have the base one that you could follow along and kind of finish up. And I have the completed one where you can try to machine this yourself. Actual feeds and speeds are very specific to everyone's machines, so you're gonna have to change that. I also tend to use work offsets. I will remove those before I upload the file, but there's something to really learn and get the hang of because it can really help your machining. So yeah, thanks for watching. Bye everyone.